Now we get to something known as the NPV profiles. So this is just a way to see in a graph form how the NPVs of two projects, we have project L and S, would change if we changed the weighted average cost of capital. So we're back to NPV and not talking about IRR. So this graph here just shows an example of the NPV profile for project L. So if the weighted average cost of capital was 0%, the NPV would be up here. If it was 5% here, 10, 15, and 20. And then just note right here that the NPV profile where the net present value is 0 crosses over right at 18.1%, which, remember, that's the IRR. And the internal rate of return is the rate that causes the NPV to equal 0. So when you graph the profile, it kind of helps make more sense when you're talking about the IRR. Now, if you have a weighted average cost of capital, sorry, if you have a weighted average cost of capital that's less than this 18.1%, then the IRR, the net present value is greater than 0, and the IRR would be greater than the weighted average cost of capital. So we would accept the project. Now, if you got to a weighted average cost of capital that was greater than 18.1%, then the weighted average cost of capital would be greater than IRR, and the net present value would be negative because it's down here in this negative range, and we would reject the project. So if we look at the two NPV profiles for project L and project S, we see their IRR for L is 18.1 and the IRR for S was, I think it was 23.6%. And so we see where they both would cross the NPV mark of being 0. And whenever you have a discount rate that's less than this crossover rate, which this is something that we'll look at how to calculate, the two NPVs are exactly the same dollar amount at the rate of 8.7%. To show you how we get this crossover rate, we would need to use the cash flow register, and I need to go back to where we had this delta cash flow column. And I would need to enter this into the cash flow register. So 0 as cash flow 0. So I'm entering this third column, or well, it's really the fourth column. Cash flow 1, these are all the differences in the cash flow. Negative 60. Cash flow 2 is 10. And cash flow 3 was 60. And I just go to IRR and hit compute. And so you see I get the 8.7% if we rounded. So that's what that column was for. And now we see that with this crossover rate, this occurs, or the NPV profiles cross each other, because one project had bigger cash flows received towards the end of the life of the project, and the other project, project S, had bigger cash flows received at the beginning of the life of the project. This is what caused these two to cross, and for us to have this situation where there's a conflict. So at rates where if the weighted average cost of capital is less than 8.7%, the IRR for S will always be greater than the IRR for L. However, at this point, the NPV for project L will actually be greater than the NPV for project S. So NPV is saying to choose L, IRR is saying to choose S. So that's a conflict in the decision-making process. Now the correct answer to this is that you always use net present value. And what we did here is we just changed the weighted average cost of capital here. Okay, Now, if the weighted average cost of capital was greater than 8.7, like we had in our example, it was 10%, the NPV for S is greater than the NPV for L, and the IRR is always going to be greater for S than for L. And so there isn't a conflict in the decision-making process. But the rule of thumb is you always use net present value to determine whether you should accept or reject a project. And this is mainly for mutually exclusive projects, like the title says, when you have to choose one over the other. Back here, whenever you have independent projects, the NPV and IRR will always lead to the same accept reject decision. So you don't have to worry for independent projects. And again, this thing is kind of, one of the more complicated concepts in this chapter, but if you have any questions, just let me know. But always know that NPV is the best and it will never ever let you down. And so here's the review of what I was doing over here on the calculator to find the crossover rate. And so we saw how to do that. Now, if the two NPVs, the NPV profiles never cross each other, then you always have one project that's better than the other. So back here, if instead of these two lines crossing, we had project S was above project L and they were just parallel to each other, project S would always be better than project L no matter what the weighted average cost of capital was. And so I mentioned the reason why the NPV profiles crossed for these two projects is because you had timing differences. And this one was project S, the project with the faster payback, provided more cash flows in the early years, which means you get a higher net present value for that one. And that's why we had the problem there. But there's also a problem when you have scale differences. Like if you have a small project, like $100 project versus $1,000,000 project, you can get a situation where the IRR for the $100 project is 100% and the IRR for the $1,000,000 project is 50%. And you have NPV would tell you the correct answer, but IRR would say to choose the really small project that hardly adds any value to shareholders, whereas NPV would tell you to choose the $1,000,000 project that adds maybe $800,000 to the shareholders. Okay, so here I just made a quick Excel spreadsheet to illustrate the size difference conflict. So here we have the small project where it costs $100 and you get $200, and a big project where it costs $1,000,000 and then a cash flow one you get 1.5 million. Well, if we looked at IRR, it would say to choose project small because it's 100% better than 50%. Whereas if we looked at NPV, it would say to choose project big because you get $428,000 that you add to shareholder value. And knowing the NPV is correct, if you chose this $90.48 to add to shareholder value versus this, you would be foregoing this minus this, or $428,000 in added shareholder value, which would be a huge mistake and you should be fired if you did this. Okay, so you're not going to be fired because you're always going to use net present value as the final method. So let me save this file. Okay, so that was the size or scale difference example. And then we have the different reinvestment rate assumptions with NPV versus IRR. And IRR is unrealistic. The internal rate of return, it assumes that projects can be the cash flows from the projects can be reinvested at the internal rate of return. So for project S, they assume each cash flow they get, they can reinvest at 23.6%. Or if it's an IRR of 50%, they assume you could reinvest at 50%. Really, almost nobody can reinvest their cash flows at what an IRR rate that you typically get. So that one is wrong. And then the NPV correctly assumes that cash flows are reinvested at the weighted average cost of capital, which makes sense. That's like the overall company's cost of capital based on, how much does it cost for them to get debt, preferred stock, and common equity. So that's really the main problem with the IRR. Even if you consider the bond, where we said that the bond's yield to maturity is the same thing as an IRR. When you calculate a bond yield to maturity and you get 8%, the only way you're really going to get 8% on the bond is if you reinvest each coupon payment at 8% in some account that you have. And that's hard to do in real life.